Now we're going to talk a little bit about reverse osmosis. These two units are identical as far as the jobs that they perform, but they just look physically different. Each reverse osmosis unit needs 3 hookups. You need a water source supply to feed the reverse osmosis unit, here and here in these styles. You're going to need a drain line, these red lines, which you're going to need to make an additional connection to your drain line under the sink. And you also have a pure water line, which goes to the bottle. On this particular unit, it's here, and this particular unit, it is here. So again, the same 3 connections, they might look a little different. The styles are slightly different, but perform in exactly the same way. Within the family of reverse osmosis, there are 2 general kinds of reverse osmosis. There's a CTA type, which is this here, and there's a TFC or TMC, which is shown here. Again, they look exactly the same, but they function a little bit differently. CTA is a type of membrane that Pure One recommends. What that allows you to do is to use the municipally dispensed chlorine into and out of the reverse osmosis unit and into your Pure One bottle. The only drawback, if there is such a thing, is the CTA type reverse osmosis membranes generate water or produce water a little bit less than that of the other style, the TFC. This CTA membrane will generate 20 gallons per day, where this TFC membrane, generates 100 gallons per day. That is also a little misleading. The gallons per day are obviously within a 24-hour period. That's also rated at about 200 psi, which you do not find, and about 70 degrees Fahrenheit, which you do not find either. So that's just a way to rate these things. Within the membrane setups themselves, another difference is the flow restrictor. This flow restrictor goes with the 100 gallon per day membrane. This larger flow restrictor goes with the smaller membrane. What that does is restrict flow out of the drain to push more water through the membrane. If you can see here, this is product water going to the bottle. This is the drain line going to the drain under the sink. If you look at the two, you could see that the drain line is flowing much faster than that of the product water. So we want to restrict that. If there was no flow restrictor, all of the water would be coming out of the drain line and you wouldn't be getting any water coming out of the product. So something you don't really need to know unless you disassemble your reverse osmosis unit, which typically you do not need to do. Getting back to CTA membranes versus TFC membranes, the CTA, again, you can put the municipally dispensed chlorine through the unit and into the Pure One bottle, which is the preferred method. It keeps your bottle cleaner. And the gravity filter inside the bottle is a real workhorse. It does a wonderful job at removing that chlorine. In that instance, with the CTA type membrane, which we recommend, you would be using a sediment-only pre-filter, our AB1, which is a 0.5 micron absolute pre-filter. It's a multi-zone filter. Starts off at 5 micron on the outside and works its way down to 0.5 micron, which is really nice for reverse osmosis. You really do not want to use the membrane to remove any solids in the water, any suspended solids, any sediment. You want the pre-filter to do that. This filter here is the AB1 Plus. This is an AB1 filter with an additional cartridge to remove chlorine. You need to do that with the TFC or TMC membranes. The chlorine will actually eat the membrane up over time, and it will not be a reverse osmosis unit any longer. So in that instance, you need to remove the chlorine, put it through the RO membrane and into the bottle without any chlorine. The gravity filter is still used in that instance as a polishing filter to make sure that your water has a good taste to it before your customer drinks it. The upside to the TFC, again, is that it generates roughly 4 to 5 times more water in a 24-hour period than the CTA. The only downside to that is you might need to clean your Pure One unit a little more often, because the Pure One unit is designed to use chlorine in the bottle to keep it clean. Again, getting back to the water flow, this flows so slowly you would not be able to meet the needs of your customers' drinking water demands. That is why the Pure One bottle is a wonderful product for use with reverse osmosis. This is a 5-gallon storage tank. So during the hours that the unit is not being used or overnight, the unit fills itself up with 5 gallons of water. During the day, the reverse osmosis produces water as it's needed, but you have a 5-gallon reservoir to drink from throughout the day. In order to use reverse osmosis with coffee brewers, you need to be able to generate enough flow to fill the coffee brewer in a timely fashion. That's where this comes in. This is a bladder tank. There's a rubber bladder in there with an air pocket. As the water fills up the bladder tank very, very slowly, it generates pressure in here. It's pushing against the bladder and the air pocket. When you go to take water out of the brewer, the valve opens in the brewer. This then relieves pressure and pushes that water into the brewer much, much faster than without the tank. So that will be an additional item needed when you're doing reverse osmosis with a coffee brewer. Drain connection. Your reverse osmosis unit will come with a drain saddle. This goes on the down pipe underneath the sink. It utilizes a 3/8 connection, and it's just what you would do is drill a hole, a 3/8 OD hole into your down pipe, your drain pipe. This goes over that hole and clamps down on it. That is under very, very low pressure, so it's not a very difficult seal to make. The water supply is your typical water supply that you would use with any water filtration unit. To meet code in some areas or most areas, you need a air gap, and what that is a disconnect point between the actual drainage system and the purification system. This is an example of a air gap. This is one that we sell. Also comes in chrome. What it does is it separates, again, the drain connection, the clear tube that would go to the sewer system, and the reverse osmosis unit, the red line producing the brine, the wastewater on the RO. There's a chamber inside where they're not physically connected. As this fills up with water, it rises up and drains down the 3/8 connection. If there was ever a backup in the sewer system, what would happen is the water would not be able to come down here, it would exit here. We have one installed in the sink. You install it inside the drip edge, so if there was ever a blockage on the drain, it would drip out of this hole within the drip edge and into the sink at that point. Now that's mandatory in a lot of locations, but you have to check your local plumbing codes to make sure. Reverse osmosis water, what it does is it removes dissolved solids from the water. Filters, water filters do not remove the dissolved solids that the reverse osmosis does. Filtration, again, sediment filtration would remove dirt and sand. Carbon filtration would remove chemicals, volatile organic compounds, such as chlorine, things like that. So the reverse osmosis unit removes things that you cannot see in the water, things that are dissolved. What we'll do here is we'll do a quick TDS, total dissolved solids. That's how you rate how the reverse osmosis unit is working, by total dissolved solid rejection. We have a TDS1 TDS meter. We'll turn it on. What we'll do is, this is reverse osmosis product water. We'll put that in there to test, and we're looking at roughly 13 ppm. What we will now do is we will check the tap water to see what they have for TDS in the tap water. We will check that again. So that is roughly 110. So we had 13 for product coming out of the reverse osmosis unit, and this is showing 111 right now coming out of the tap water. So that's about 100 ppm drop through the membrane. What we'll do is we'll do a little math equation to determine the rejection rate of the reverse osmosis unit, and usually anywhere between 75 to 80% rejection is where we want this thing to be. No less than that, and at that point where it might drop below 75%, which in this case it is not, we would want to replace the membrane. To replace the membrane, what we need to do is open up the reverse osmosis vessel, which is this larger 2.5 diameter unit. They're the same diameter, the same length, because these membranes fit in these housings similarly. On this particular unit, an older style, you would have to undo the fittings. Maybe you want to make sure you write down yellow, blue, white, black so you know where they go. They're also located on the cap. From filter, membrane feed, to waste, and product out. Unscrew these, open up the cap, pull the membrane out. You can use a pair of pliers if it's in there. The new membrane, when you open the bag, you do not want to touch the membranes with your hands. You want to cut this open with a knife or something. Hold on to the outer plastic bag as you feed it inside the vessel. Again, do not touch that. Once the new membrane is installed, tighten the cap hand tight, reconnect your fittings. The unit must run, we recommend, about an hour. What happens is when they manufacture the membranes, they use a preservative in them to keep them from fouling. That preservative must be flushed out. When you start running this and you do a TDS check, on the first few ounces of water that come out, the TDS is much, much higher than the tap water supply TDS. Which you say, how can that be? How can there be more coming out of the membrane than is going in? That is from the preservative in the membrane. Slowly over time, it starts to come down to where it will do its 95% rejection, 99% rejection, depending on what the tap water supply TDS is. And then in about an hour, you should have great tasting water. The reverse osmosis membrane is now broken in. All of the preservative is flushed, and it's rejecting anywhere from 99 to 95% of the total dissolved solids in the water.